All right, so on page 140, this was on the review from the other night. This is problem number 13. So number 13. So two things. You will have the ability to use a graphing calculator on the test tomorrow. If you don't feel comfortable with it, you can still do it by hand, and you're still going to get the points for it, right? So if you might as well try it, but let's go through number 13 using the graphing calculator. So I'm going to go through it pretty slow. I'm going to go, first thing, I'm going to turn it on, enter my y equals. I'm going to clear out both items that were there. I'm going to go second quit on that. I'm going to go to stat, edit, and I'm going to clear out the old data that would have been put in there. So remember, you go up, clear, and then down arrow. Then you go up, clear, and then down arrow. And this says the following data represents the height of a child in inches versus the age in years. Use a graphing calculator to sketch a graph, then answer the questions referring to the graph and the table. Okay, so it looks like ages 1 through 8 are listed. So from age 1 to age 8, and the Y-intercept, or the Y information is the how tall a person would be in inches. Okay, so under L1, I'm just going to, oops, if you make a mistake, just go back up to it. And then I'm going to plug in the inches, so it looks like 24, 28, 33, 38, 41, 45, 48, and 51. Okay, so that's the data for the graphing calculator. Okay, this would probably be pretty easy to do by hand if you needed to. Okay, obviously you can make your x values pretty easy, count by ones, and then your y values probably count by fives. That'd probably work for you getting a line of best fit. Okay, so use the linear regression capabilities of the calculator, create the line of least regression. We're not going to do that, but we're going to create the line of best fit. Okay, so I can do a few things. I can hit zoom and then stat, so I can see my data plotted, is what it'd look like. If it was on zoom, you have your zoom stat has to be on in order for this to take place. So now let's find the linear equation. So I'm going to go stat, calculate the linear regression, which is number 4. Enter, list 1, list 2, yep. And some of the earlier versions might not be a little different, but we'll just say mine. One more coming. One more. Thanks, guys. So we calculated. This is my linear equation where the a value is my slope and my b value is that. So my a value is my slope. What does 3.90 as a slope mean in the context of this problem? Yeah.
So for every year in the child's life, it grows 3.90 inches.
Right. For every year, or 3.90 inches is grown every year for a child, or something like that. Okay. What does the y-intercept indicate on this problem? Remember, where does our data start? It starts at what? What is the x component of our value? 1. So what does the y-intercept mean in the context of this problem? What do you think? 0. Yeah, when the child is born, they average 20.9 inches in length. Okay, is that exclusive for everybody? No, everyone's a little bit different, but they're just taking some data and applying it. Okay, so if we wanted to plot our line of best fit, you go y equals, and you go under vars, under statistics, which is number 5, go over to equation, and you're going to put in the regression equation, you hit graph that way, that is the line of best fit, and that looks pretty good for that data. Okay. Use your equation to estimate the height of the child in 12 years. Our window isn't big enough to see 12 years. Our window right now goes out to 8. So I'm going to zoom out. Good. So I'm going to go zoom out, enter, and that's what it's going to look like. Now I can figure out how tall the kid is at 12 years of age. So you can do it one of two ways. You can plug that 12 into your linear equation, or on the calculator you can go second calculate. I'm calculating a value when x is 12. So when x is 12, notice where the little cursor is on the graph. That means that you came out here to 12 and you went up to this right here. And so the child should be 67.78 inches in height, or 68.79 inches in height. And then what does the slope represent? We already talked about what the slope represents in this question. Okay, so that's a great type of question to see. The hard thing is sometimes when you're looking at data, everyone wants to think about that outlier. Don't consider the outliers. Okay, it's like when we go to the thing, hey, this is how many years, I told you about my buddy Bill Ebright, who is a multimillionaire, who never graduated from high school. Is he the norm? No. Okay, so there are definitely places that people might get lucky in life, and that shouldn't be, oh, that applies to everybody, therefore. It doesn't apply to everybody, so, cool. Thanks, man. Getting all kinds of stuff today, by the way. Yeah. Hey, another! Holy cow, thank you. Okay. Guess what, Angie? No.
Did you throw another plate at a kid?
For like the 4,000th time this year. Right? Did it say now? I don't know what it said. Yeah, I didn't either. I'm glad you're like me. I don't read it. It's up to you if you'd like to go to it. Okay. All right. Problem number 14, which is on page 141, talks about Alex decided to collect data to show how fast he could type on a computer. Refer to the data table below, answer the following questions, change the y-axis to hundreds, and top to 1,000. Yeah.
How do you find a y?
Oh, on this? All right, so if you knew the kid, let's say you wanted to know how old the kid would be when they are 35 inches, you would do this. You need to make a horizontal line. So you're going to go y equals, you're going to go to y2, and we said 35. So if that was the case, and if you hit graph, you're now going to look for the intersection of that line right there. And that's under second trace or calculate. We're going to find an intersection. First line, second line, guess, no, third line. So when the person is 35 inches tall, they are 3.6 years in age. Okay? All right. We don't need this up there anymore. Let's get rid of this. Come on. All right. So it looks like they want us to create this data. So I'm going to use math, graph. Looks like I'm going to just use the quadrant graph, which is this. I'm going to remove my numbers. And it looks like they're going every other one count by 20s. So get 0, 20, 40, 60, 80, 100. Uh-oh. Yeah, but that's all right. And then that was in minutes. And then this one's going to count by up to 100. So we're going every other one. So again, let's just change colors. 0 here, and 20, 40.
You're supposed to go by
It goes in
hundreds.
400s.
It
Oh.
Change it.
directions.
Thank you. I was just looking off with the grid head. But start with 0, right?
Yeah.
What does it do? Count by
Count by
hundreds. All right. 100. Wait. Count by hundreds. All right. 100, 200, 300, 400, 500. All right, cool. And that was in words typed. Okay, so if we wanted to start plotting our data, they're just x, y values. So at 10 minutes, we're at 165. At 20 minutes, we're at 315. At 30 minutes, we're at 468. At 50 minutes, we're at 765. 60, I'm at 920. 70, I'm at 1080, so even up here. Okay, so that's basically what my data looks like. We'll do the best we can drawing a line of best fit. Like that. Okay. Should this be close to our data? Yeah. Is that really going to be the perfect interpretation? It'd be all right. So the best thing to do is think about 2 points that you might want to pick on your line of best fit. So I might pick this piece of data, and I don't know, maybe this piece of data. They're far enough apart. They both lie pretty close to my line of best fit. It'd be wise choices for me. So the first piece of data is 10, 165. And then if I chose 1, 2, 3, 4, that's our fourth piece of data. 1, 2, 3, 4. That's 400, 6 or 40, 600. Okay, create a scatter plot of data given on the axis. We have it. It's labeled. Pick 2 points and sketch the line of best fit. That's where we're at now. So I picked 2 points. Okay, some people might have said this one and this one. That's fine. We're going to be pretty close. We might be off a smidge, but that's okay. So remember, first thing we want to do is we're going to find the slope. Just label x1, y1, x2, y2, and plug in our values. So I get 600 minus 165 over 40 minus 10. So that's going to give me, if you have a calculator, help me out, please. 435 over 30. It's like 5 goes into both top and bottom. 5 goes in the top 87 times. 5 goes in the bottom 6 times. So that's what our slope is. Okay. From that, I'm going to use my point slope. Again, we'll give you these equations. My x1 and y1 were already labeled up there, so I'm still going to use them. Okay. Write an equation, line of best fit. That's your equation. You might want to solve this. Somebody do me a favor. Go 87 divided by 6. 14.5. Thank you. Distribute that over. then let's add the 165. If you add 165 to both sides, I get this. Add 165 to negative 145, I get plus 20. Okay. That's our equation that's graphed there. Use your line to calculate the number of words typed in 25 minutes. Minutes is the x value, right? So if I want to figure out 25 minutes, I'm going to plug 25 into there. So I'll just plug it in over here. And if you have a calculator, this would be best. Or you can sit there and just stare at the board going, how do you get that? That was less than 5 minutes. Good deal.
382.5.
Say that one more time.
382.5.
282.5.
382.
Over that?
382.5.
382.5. So you think about 25 minutes. That's like here. So this is between 3 and 400. Yeah, 382. Sure, that seems okay. Your goal is to reach 2,000 words according to your model. How many minutes will that take? So 2,000 words, we're way up here, right? Even higher than I can reach. Let's bring this down. So my equation that we have is this. And you want to get to 2,000 words. Which variable is words? X or Y? Y. So I'm going to plug 2,000 in for Y. I'm going to subtract 20, so that's 1980. Divide each side by 14.5. So 1980 divided by 14.5 is 136.55. Sweet. So that's how many minutes it would take you to get to your 2,000 words based on our model. Yeah.
So for E, I got 131. So I just wanted to know like how much slack you would give us.
So what I do when I grade this problem is I take a look and I'd be like, okay, you chose the same points as I did. If you didn't, I realize you chose 2 points that are making sense to you. So I know that there's, what did you get, 131? Oh my gosh, you're 100%, you nailed it. Yeah, it's when you, like let's say my 2 pieces a day came up with 136.5 and you come up with 4,227. It's like, ooh, that's way off. No, but that, like your kind of thing, I mean, you're talking two different values are going to create very different lines. I mean, if you picked this and this is the line of best fit that fits between those. That's the equation. That's very different. If you chose like this one and this one, well, that's pretty close. If you chose this one and this one, you know, all your lines of best fit, it depends which 2 points you pick. If you pick the identical points that I picked, which would be coincidental, there's nothing to say that you would have to pick those, and then you were wrong, then I can say, okay, you made a little mathematical error. But you're totally going to get small errors and deviations from what's chosen because it just depends how you draft it. And it's like a lot of times a line of best fit is your judgment call on which 2 points you want to use. You know, the rule of thumb is I wouldn't use 2 that are right next to each other. One way to say, people will say it is take the 2 points that are furthest away. Someone else might say take 2 points that seem to lie on your line of best fit. What's the right answer? It's all right. There's not an exact science. The nice thing is when you do it on the calculator, everyone's calculator is going to do it very quickly and real similar. It'll be a lot closer on the calculator. Okay. This take-home test looks very similar to what you would be doing on the test. And we have to test tomorrow. Okay? So, again, I'm going to go through slowly. Stop me where, we have 30 minutes to get this done. I'm pretty sure problem number 1 and number 2 are solid. Problem number 1 and number 2, there were the 2 strange scenarios. One of them is you get the 0 on top, which means your slope is what? 0, good. And then the other strange event is you get the slope on bottom. So the slope of the 0 is on the bottom or under. So that is a undefined. Okay? So you could get a positive slope, you can get a negative slope. You can get a slope of 0 if you get the 0 on top. That would be your y values cancel out. If you got a 0 on bottom or your x values cancel out, it's a vertical line. That's an undefined slope. Okay, so 1 and 2 should be fine. I've just done your test. I didn't go work it out. I can't tell you if you're going to get undefined or 0, but just keep it in the back of your mind. If you get 0 on top, it's 0. If you get 0 underneath, it's undefined. 3, 4, and 5. Those are handed to you. They're already in slope-intercept form. Is everybody okay with 3, 4, and 5? Take a look at it. This is your opportunity to say, man, I'm a little stuck. The only place I might see is number 4. What are you missing? Y-intercept, so it must be 0. Okay? So 3, 4, and 5. Number 4, you have a y-intercept of 0. It just doesn't exist there. Okay, so are we okay with 1, 2, 3, 4, and 5? Is there anything that you need to ask me about those particular problems? Everyone feel pretty solid about those? Okay. 6, 7, 8, and 9. They want us to put it in y equals mx plus b form. Problem number 6, it's handed to you. Why do I say that? Yeah.
Because it gives you the slope and
Yeah, it gives you slope and y-intercept. It gives you m and b. You just replace m and b in y equals mx plus b with y equals negative 1/4 x plus negative 3, or just minus 3. It's your choice how you want to write it. Okay? Number 7, you have to do the 3 steps in order to get through it. Okay? You have to find the slope first. Well, before that, you have to label x1, y1, x2, y2, right? Anybody need number 7 seen? 3 steps, okay? It's 3 steps. Every time it's the same 3 steps no matter what. Okay? I'm given these points. x1, y1, x2, y2. Doesn't change. Slope equation. You'll be able to find the slope equation someplace on the test. I'm not going to tell you, here's the slope equation, so on number 7, find the slope first. Okay, so I have 1 minus 4, 3 minus 0, so I get negative 3 over 3, which is negative 1 is my slope. Good? Are we done? Nope. Now I need to use point slope. Point slope will be somewhere on the test. You got to figure out where to find it, where to use it.
We already have this y-intercept.
Oh, we happen to do. Cool. So we do have the y-intercept. So just in case you didn't see it, cool. We'll just do it this way. But you're absolutely right. We have the y-intercept given because that's 0. So I'm going to go y minus 4 equals m, which is negative 1, x minus 0. Distribute that. Negative x or negative 1x. Add 4. So my equation of y equals mx plus b is this. Okay. Number 8. Anyone need to see number 8? Okay, I give you the slope and I give you a point. So problem number 8, you start with this. Your point, you label x1, y1. You're given your slope. Plug it in. Number 9 is just like number 7. I need to go through all the steps. I have to label x1, y1, x2, y2. It's the exact same process. Okay? Don't fear the decimals and fractions and the negatives. Negatives just don't disappear. Number 10 and 11, bless you. That's where you're starting. You need to use this equation right here over and over. Does anyone need to see 10 or 11? Are you okay? Okay, you're using the point slope equation, plugging it in. It's given to you. Yeah.
Wait, do you just want us to write the equation for that one?
Uh-huh. And you could just leave it just like that. It says write the equation in point slope form. You literally plug in your x1, y1, and your slope, and you're done. Don't do anything else. It's like, here you go. I guarantee there's going to be students in here that leave it blank. And that saddens me because it's such a gimme. Okay? 12 and 13, we want you to write the equation in slope-intercept form. Y equals mx plus b. Does anyone need to see 12 or 13? over 13. Again, this is doing all 3 steps up there. We okay with those?
You do 13.
Yep, 13, here we go. 4, 0, negative 2, 3. First step, label x1, y1, x2, y2. Didn't change. Slope equation is this. Again, find the slope equation. It's going to be located someplace on the test. You have to know when it's used. 3 minus 0, negative 2 minus 4. That's 3 over negative 6. So that's negative 1/2 is my slope. Next step, use our point slope equation. Again, this is located all over your test. Know when to use it. Okay, I've already labeled x1, y1, so don't change it. Okay, y minus 0 is just y. That's set. Distribute here. So I get 1/2 x. And then half of negative 4 is 2. There's my equation. Done. (14) and 15. I know people struggled with this on the last one, so I'm going to hit number 14. I have y equals negative 3 over 2x plus 4, and I have the equation y minus 1 equals negative 3 over 2x minus 2. This is in slope-intercept form. This is a slope of negative 3 over 2. This is in point slope, so that's your slope. Slopes are both negative 3 over 2, so are the slopes the same? If they are the same slopes, does it make them parallel?
Yep.
Yes. So parallel, what's the reason? The slopes are equal. Okay? Problem number 15 made it a little tougher. One of them they gave you in slope-intercept form. That's great. The other one, they have it in standard form. Okay? Slope of this one is straightforward. It's 2. This one, we have to modify it. Subtract 4x. No matter how hard we try, we can't subtract 4x from 6, so we just have to write it. Where did the plus come from in front of the 6? It's a positive. Divide everything by negative 2. So y equals 2x minus 3. What's the slope of this line now? 2. I have a slope of 2, I have a slope of 2. Parallel or not?
Yes.
Yeah, parallel. Why?
Same.
Slopes are equal. Done. Simple as that. 16, 17. Students have problems with those. The same thing, but you're looking for perpendicular. Remember, perpendicular is the flip over the fraction, opposite sign. Right? Number 16, we got y equals negative 3 over 2x plus 4. And then I have y minus 1 equals 2 over 3x minus 2. This is in slope-intercept, so my slope here is negative 3 over 2. This is in point slope, so this is my slope right here. First thing, are they opposite signed?
Yes.
Yeah, one's positive, one's negative. There's our first clue. Second clue, are they flip over fractions?
Yes.
Yes, these are perpendicular. You say slopes are opposite sign flip overs. Okay, not even using the word reciprocal. No one knows where reciprocal is. Flip over sounds makes sense. 17, same idea. You have y equals 2x plus 5. You have y equals negative 2x plus 6. All these are just given to us. I have a slope here of 2. I have a slope here of negative 2. Are they opposite sign?
Yes.
Are they flip overs?
No.
No. Are they perpendicular?
No.
No. They are not. You could say slopes have negative or positive and negative, but not flip overs. is a reciprocal. They are not perpendicular. How we feeling?
Good.
Awesome. Yeah, we're doing well. Okay, let's hit that word problem. It's a hose. Okay, water for the most part flowing out of your hose when you have your spigot all the way open flows at a constant rate. Okay, yes, it does deviate when someone flushes the toilet in the house, and we're not worried about that. Correct? So a hose is being used to fill a pool in the backyard. The hose is pumping water at a rate of 15 gallons per minute. 10 minutes after you started, the pool now has 350 gallons in it. Cool? So, what is my slope in the context of this problem? It's given to us.
15x.
Talk to me. How's it going to work? Tell me what it is.
So for every minute, the pool gets 15 gallons.
So the slope is 15 gallons per 1 minute. How do we know that? Well, it says a hose is pumping water in at a rate of 15 gallons per minute. Rate and slope are the same thing. So slope is equal to 15. Sound okay? And then it says 10 minutes after you started, you have 350 gallons in the pool. Okay? Now, does this mean, could there have been water already in the pool?
Yes.
Yeah, it rained last night, but now I turned my hose on to fill my water up. Okay? So, I need to figure out my equation. So, my, let's see, okay, what is the x variable? And what is the y variable? So, if I were to graph this, would I have minutes here?
Yes.
And I'd have gallons here?
Yeah.
Gallons here? Did that make sense? Go turn the hose on. Okay, it's going to flow out at this rate. Okay. Okay, so the x variable is time. Y variable is gallons or gallons of water. The rate, the slope is gallons per minute. Okay, so we could say this is time in minutes if we wanted to. That's all they ask on this. That problem's done.
There's the backside.
Oh, there. Oh, thank you. Write an equation that models how much water is in the pool. Okay. So now we're going to write an equation. Write an equation. I'm going to use this. The reason I'm using this is because I know what a point is and I know what the slope is. This is going to be x1, y1. Plug in. 15 is the slope. X minus 10. It just says write an equation. Is that an equation?
Yeah.
It's totally done.
Wait, but it asks for the y.
Oh, it's going to ask for other stuff later, huh? So, if you were to leave this just as your equation, you're fine. You might have to modify it to y equals later. So I'm going to distribute the 15 over the parentheses. And then I'm going to add 350 to both sides. So that is just that modifier. Explain what the slope means. The slope means for every time 15 gallons of water is added to my pool, 1 minute has taken place. A lot of people want to say for every minute 15 gallons goes in the pool, but the slope is the rise over run, the x, y component over the x component. Okay, so for every 15 gallons of water I put into my pool, 1 minute took place. Yeah, or 15 gallons per minute. That works. Explain what the y-intercept means. What's the y-intercept? 200. What does that mean?
When we started pumping.
Yeah, it rained last night. We got 200 gallons of water put in my pool. Are you snoring? Okay. I think you snored. All right. So there, before we put the hose in the pool to fill it back up, there was already 200 gallons of water already in there. Yo. No, you're just waving at me. I thought you were. So that's what the Y-intercept means. How much water will be in the pool after 60 minutes? What variable is minutes? X or Y? X. Okay, so I'm going to plug 60 into there. So I'm going to get Y equals 15 times 60 plus 200. I don't know what that is. Help me out. 1100 total. So after you add your water on for 60 minutes, which is 1 hour, your pool now has 1,100 gallons in it. Cool. We're all done with that one, right? All right. The table below gives the data relating to the number of oil changes per year to the cost of car repairs. Plot the data on the grid provided. Make a scatter plot. Okay? I'm just going to make a scatter plot by hand rather than try and use the one that's given me. Okay. What should I label the x-axis as? Oil changes. What should I label the y-axis as? Cost of repairs. Okay. Looks like I go from 1 to 10 here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that okay? I guess I could put 2, 3, 4 in there, 6, 7, 8, 9. It's up to you. Cost of repairs looks like it goes from, I'd say I'm going to count by hundreds. So 0, 100, 200, 300. Try and space them out even more. 400, 500. All right. So 3 comma 100, 3 comma 100 there. 5 comma 300, 2 comma 500, 3 comma 400.
Wait, the first point was 3 comma 300. You labeled it as 3 comma 100.
It says that on the, no, but it said it has 2 points.
I have 2 of them, right?
Yeah, you're.
Oh, hang on.
Wait, no.
Oh, I see what you're saying. I see. This one's an error. Is that what you're saying? Yeah, you're right. 3 comma 300. I'm sorry. That's right, like that, right? Okay. 1, 2, 3, 4. 1, 2, 3, 4. 1 comma 700. 4 comma 400. 6 comma 100. 4 comma 250. 3 comma 450. 2 comma 650. 0 comma 600. 10 comma 0. 7 comma 150. Okay, that's pretty ugly looking data. I wouldn't go just, I mean, it looks like it has a negative correlation to it. I mean, the more oil changes I get per year, the less I'm going to have to pay for my car. You do a line of best fit, I don't know, something like that, or something like that, or something like that, okay? Which is the one that's going to work best for you? I have no idea, okay? Now, here's one that people might think is the best method. Let's choose the 2 that land on the x or the y-axis. I don't know if that's the best choice or not. That's kind of an outlier a little bit.
600 to 10.
I don't know, maybe pick that point, which was 1 comma 700. And I don't know,
Go to
Here? 7 comma what? 150? Maybe. You might have chosen 2 different points. That's okay. You're going to be pretty close. I'm going to get that you're going to have a little bit of wiggle room. Okay? We're just answering the rest of the questions. Draw the line of best fit. Any of those purples are going to be fine. Find 2 points on the line. We did. Use those 2 points to write an equation. Okay? So I'm going to use these for my equation. Here's my slope. X1, Y1. X2, Y2. Almost done. Give me a chance. 150 minus 700. If you have a calculator, it helps me out tremendously. M equals, what is that? Negative 550 over 6. Let's make it easy. Let's make it a decimal. 550 divided by 6 is?
Negative 91.66.
Okay? This is easy to relate to what the slope is. I saved $91.66 for every oil change I get on my car. Okay? What does the Y-intercept mean in the context of this problem? Well, let's figure it out. Let's figure out what our equation is. Y minus Y1 equals M times X minus X1. Y minus Y1, Y1 is 700, 91.66 negative, times X minus 1. Got to squeeze it. All right, bring this over this way. Y minus 700 equals negative 91. What'd I do? Add 700. What does the Y-intercept mean in the context of this problem? Don't get stuck with going, oh, we know what the Y value is. It's here. It does that says that's what our data states, but it does not state this is what our Y-intercept means. This means that if by looking at our data, looking at our information, figuring out the line of best fit, using the equation, if I don't get my oil changed ever on my car, I'm going to have $791.66 of repairs having to be done. Okay? Don't take the data point as the Y-intercept. Make sense? What is the predicted cost if I had only one oil change? Don't use our data. Don't go, oh, one this. No. One oil change. Oil changes is on the X. Plug a 1 in here. So I get Y equals negative 91.66 times 1 plus 791.66. If you have a calculator. 699.99. So if you get one oil change in the year, looks like you're going to have almost $700 worth of repairs. Do we under or over predict the cost for someone who had 5 oil changes? 5 oil changes. Okay, if I had 5 oil changes, I'm plugging a 5 in there. What is 5 times negative 91.66?
Negative 458.
Negative. Add that to 791.66. 333 point what? 36. Okay, did we under or over? So 336. Maybe about there. 5 oil changes? I don't know. 5 oil changes. Let's look at our data. 5 oil changes. 5 comma 300. We're saying it's 331 or 333. Our data says what? Yeah, so we're kind of over. Does that happen? We don't have a whole lot of data here to say, hey, we're going to make a judgment call. But that's, if you know how to do that. Everyone get that done?
Yep.
Putting 5 points in for you right now, so make sure you all put a top mark on that sheet for you. Do not turn it into me. Use it to study. You have the test tomorrow. Agreed? Right?
Yep.
Okay, you know it's expected, right? All the equations are going to be listed on there. You just have to find them. M equals a slope. Y minus y1 equals m times x minus x1 is point slope. Y equals mx plus b, slope-intercept form. That's all we got. If you want to come see me, you guys know where my office is.